Thank you everybody for being here today. I'm super excited to be in this first in-person Pulsar Summit conference. That's a conference that I've been speaking at it for the last 2 years on the different editions, but online, so we didn't have this. So this is very cool to have all of this. So the title of this presentation already explains everything, what is the objective, right? So when I was submitting this talk to the conference, I was thinking about, all right, maybe I would like to explain how KoP works and maybe give an example how to configure, so that would be it, right? So, but then I was wondering, all right, but Ricardo, that's a question, right? It's a question about yes or no, right? So I start wondering what I could do to actually kind of shows up something that's could be feasible. And I spent a lot of time thinking, and doesn't matter who I am, let's skip to the part. We can talk later in the show. So then one of those Saturday nights I was sitting up with my wife and was watching this movie. Not sure how many of you have watched this movie, How to Lose a Guy in 10 Days. It's a kind of a romance/comedy movie where the actor of the character of Kate Hudson tries to prove that she can kind of get rid of any guy committing the same mistakes that women do, which is obviously when you say that out loud, you start realizing that it's still not inclusive at all, right? So these days, I think we should change the title for How to Lose a Person in 10 Days, not a guy, right? And not the mistakes that women do, the mistakes that people do, right? So back in I think this movie is from 2000, right? I think that back then, people were not so concerned about those things as we are right now. But point is, I was watching the movie, and then the whole plot of it, okay, so she's going to use a systematic approach to prove a point by following a set of kind of scenarios, right? And then my wife was always, are you listening to the movie and watching with me? And that was me, literally, when I was figuring out, say, that's what I should do. I should really kind of follow up with a bunch of scenarios that I could prove that I could get rid of with the KoP. So I kind of brought this to you. So that will be the ideal title for this presentation, where I will be the Kate Hudson character trying to get rid of KoP, trying to prove that, all right, if I follow those steps, it won't work. Because I am a very pragmatic person. So when I first heard about KoP the first time, I said, oh, you can expose a Kafka protocol in a Pulsar broker? No way. All right, this is magic. This is voodoo magic. It can work possibly, right? So it's going to be me against KoP, right? So I'm not going to answer the question, is Pulsar using KoP a good idea? Because I want you to answer that question after the presentation, right? So that's it. All the slides that I have, everything that I'm going to show today for you, it's here, all right? So take your time to take a picture, because I would like to encourage you to actually clone this REPL, follow the instructions. I'm actually going to do that for you live, right? And I'm not going to follow any script because everything is already up and running here, and I'm basically going to follow all the instructions that I've wrote there. So if it doesn't work here, it's not going to work for you, and vice versa, right? Vice versa, doesn't make any sense? No, I don't think so. But anyway, thank you very much. That's it for today. I'm kidding, right? I'm just going to switch to the demo. All right, so let's get rid of this. Let me explain something, because you're going to see that I'm going to keep switching windows from time to time. And again, don't worry if you can't see the characters. The only thing you have to understand here is that I currently have a Pulsar cluster up and running with 2 brokers, 1 zookeeper, 2 bookies for the persistency layer, and 2 brokers, right? So the windows of the brokers are this one. I call it Kafka 1. It's kind of a very courageous of me, right? In a Pulsar Summit conference, calling a Kafka Pulsar cluster as a Kafka, right? But let's pretend it is a Kafka cluster, because this is the promise of KoP, right? Is for us to think that we are talking Kafka into Pulsar, right? So Kafka 1, Kafka 2, all right? So let's start with the scenario. So that's the repository that if you took the picture, you're going to clone it and play with. So there's a bunch of blah, blah, blah. But basically, what I've did here is I've created 3 different scenarios. Because remember, I'm a pragmatic person. So testing if KoP works should be much more than, oh, yeah, I can produce a message to a topic. Yay! Yeah, I can consume a message for the topic, because this is bread and butter, right? That's the basic what the KoP should do. In the real life, people using Kafka are often divided on these 3 different scenarios over here. Either they're using Kafka for communication asynchronous, their microservice, use case number 1. Either they're using Kafka to maybe implement some CDC, change data capture, to listen to the changes from a relational database and replicate those changes for a purpose-built systems, right? Situation number 2, or stream processing, right? Just like the amazing Cato just showed us with Apache Flink, maybe they're using either with Apache Flink, Kafka Streams, KSQL DB, whatever, but on top of Kafka. So I thought, let me put KoP to the stress in these 3 different scenarios. Let's do this. Let's start with the microservices one. So for the microservice one, I actually wrote a microservice in Spring Boot. Let me show the code because this is another movie reference. As you can see, I'm a huge fan of movies, right? So how many of you have watched that comedy movie from, with Adam Sandler and Drew Barrymore called 50 First Dates? Okay, right, not a lot, but that's a start. All right, so the whole plot of the movie is that the character of Drew Barrymore, she suffers from a condition that she forgets every single day, everything from the past, right? So Adam Sandler has to literally make her fall in love with him every single day, which is a tough task, right? And then, in the middle of the, no, not middle, but I think in the end of the movie, there is this character called Tom, which suffers for the same condition, but even worse, because he forgets every 10 seconds. So he was kind of got a nickname called 10 Seconds Tom, right? Because every time, 10 seconds elapse, and then, hey, I'm Tom. And he just met you, he forgot about this. I just decreased it from 10 to 5 because waiting for 10 seconds to show a demo is not very wise. But the point is, what this Spring Boot microservice does, I have this annotation at schedule that every 5 seconds is going to use Kafka templates and produce a message to Kafka, right? And then the same Spring Boot is using the Kafka listener to listen for the messages and, hey, I'm Tom. Hey, I'm Tom. So if you keep saying, hey, I'm Tom every 5 seconds, it means that it's producing and consuming message from Spring Boot, okay? That's the challenge because, again, the Spring Boot, what it is a framework constructed on top of another framework with the Kafka clients, which in turn talks with the Kafka protocol. So that's the challenge. Everything has to work. So let's see this thing working. New terminal. I'm going to fire from here, and I'm going to actually use the instructions that I've wrote, which says, run the Spring Boot microservice. And so I'm going to copy. Let me just check if the brokers are up and running. They seem to be. They are. If they keep popping up, yeah, the health check. So let me run the Spring Boot microservice. So here's why it's running, and in a minute it's going to start saying, hi, I'm Tom, hi, I'm Tom. So here's what's going to be the test. Yeah, first test if the protocol in the library client API level, KoP allows this, right? And by the way, see, hi, I'm Tom, hi, I'm Tom. So that's a first, that's a first check. The second check is that if you think about it, Kafka is not a client-server protocol. It's not just I send a request, the brokers understand and translate the request and reply back. It's a multiplexed bidirectional protocol because the broker keep pushing messages to the clients as well, right? For example, the whole concept of bootstrapping, what it is. Periodically, the metadata from the whole cluster formation is pushed to the clients. So what I'm going to do is I'm going to find who is the leader of that partition in Pulsar. I'm going to kill that broker. And what needs to happen, and by the way, that script that I've just executed only provides one of the brokers as parameter. You see? There are 2 running on port 9092 and other 9093. It has to fall back to the other broker because if it falls back, it means that the clustering protocol is being replicated. And KoP is doing that. All right, so let's try that out. So there's a command that you can run called lookup using the Pulsar CLI that you can use for this. So let's run this command. And what this command is doing right now, I'm finding who is the leader of the partition. In other words, which broker the Spring Boot application is writing the messages. Okay? which seems to be the Kafka 2, right? So I'm going to enter that folder, and I'm going to kill Kafka 2, so, which is this gentleman over here, okay? So 1, 2, 3, and kill it. Let's see if it was killed. So as you can see here, this is a Docker PS that I keep running. I just killed the container for Kafka 2. So only Kafka 1 remain. And if we look back to the microservice, there's a lot of errors popping up because Kafka's client's API is very resilient. So it's keep retrying. And eventually what needs to happen is that, OK, I'm tired of trying. So I am going to fall back to somewhere. So somewhere between the next 5 seconds, it has to fall back to the other and continue the processing, all right? If that doesn't work, what it means? At a client level, it works. You've seen it. But if it doesn't fall back, hey, it worked. I'm done. You see? If it works, it means that the KoP protocol is capable of not only mimic the client API, but the Kafka protocol, the clustering protocol. And that's a very tough challenge. It's not very easy because the Kafka clustering protocol is a very complicated one for the client's API. Think about the rebalancing API for the consumers, for example. So how to manage this, it does it beautifully. So the first jack is good, right? So I think we're good in that part. So as you can see here, the Kafka 2 is down. I'm going to actually start up the brokers. And then I'm going to view the log of the Kafka 2, which is bootstrapping right now. So I'm starting from scratch, right? While it's bootstrapping, let's go to the second scenario, which is, CDC with Debezium and MySQL, all right? So before we move forward, let me just show you something here, because that's probably a question. For the Kafka broker 1 and 2 that I've just showed you, this is the Docker Compose I'm using. So as you can see, I'm using the image from Stream Native, right? And how do you enable KoP? Basically, you have to create a folder called protocols in the same folder of your Pulsar distribution, right? Protocols. And you put the NiFi archive of your protocol handler for Kafka there. If you do this, you don't have to do anything. All the protocol handlers are going to be loaded up during the bootstrap. What you have to do is to say which protocol handler are you going to be using? Ricardo, why? Good question, because you have a lot of protocol handlers. You have Kafka, you have AMQP, you have JMS, and I think there's MQTT. Am I right, Tim? MQTT, right? OK, so there's 4 of them. So you have to specify which protocol handler the broker is going to be using. Other than this, you're going to see there's a lot of properties that looks like a lot with Kafka does, with listeners, advertisers, and things like this. OK, meanwhile, everything's up and running. All the brokers are healthy again. So I'm going to jump to this tab here, and I'm going to run another script. Where's my terminal? OK, so I'm going to run another script called start CDC with Debezium. What this script does is to, here you go. It's going to spin up 2 more containers. One is a MySQL server from this Debezium distribution. It's kind of a demo distribution from Debezium, right? That has a couple tables and fields with data. And you have a Kafka Connect, which happens to be trying to connect with the same Kafka 1 and Kafka 2. So where's the role of Kafka Connect? It's the integration platform. I'm going to deploy a Debezium connector, which is going to keep listening for the changes in MySQL, and everything that happens there is going to be replicated to a Kafka topic. That's what Debezium does best, right? So let's see actually, let's follow up here. View the logs of Kafka Connect. It should be up and running at this point. If not, it's on its way. Let me see the health. So MySQL is up and running. Debezium, not very much. I'm a little confused here with the terminals. I can get rid of this one. OK, this one. So let's see the logs of the connect. So here's one thing. Allow me to queue the Kafka Connect for a second. And I'm using a MacBook Pro with the M1 chip. And one of the things that I've noticed recently, especially when I was creating this demo, is that sometimes the containers, they simply freeze. If you're using an Intel chip, this doesn't work. I know this because I've tested it at home and that I have a Linux box. So from time to time, you're going to see that I will have to kind of get up and down the containers, but this is not a KoP problem. Just know this, okay? Let me put the blame on the Apple this time. So you see, it was frozen, and then you just have to reboot the container. It works. Don't ask me why this happened. But the point is, Kafka Connect is now trying to connect with the cluster. Eventually, it will connect. And when it does, I will deploy the CDC connector from Debezium. And I think no, not yet. Yes, finish starting connectors. So let me do this. I'm going to deploy, actually before that, let me show you the MySQL table. I'm going to connect to MySQL, and there's a table here called customers, which has some rows already inserted, right? So now that we know there's a MySQL server, I'm going to actually, okay, I did that. I'm going to deploy the connector, which is essentially doing this in the Kafka Connect word. You basically do a post, and then you are going to submit in this post a configuration file that dictates how the connector property should look like. Basically, where is the MySQL server, username, password, blah, blah, blah. So I'm going to deploy it. It seems to have deployed, so we can double check that by doing a get to get the information about the connector, and we should get a response. So yeah, the connector is deployed and it's running. Kafka Connect is called tasks, so there's one task up and running that is pulling MySQL for CDC purposes. So what I'm going to do now is I'm going to start a plain old Kafka console consumer to read that topic that is associated with the customer's table, right? So right now, Kafka, I'm saying Kafka this way. Kafka is listening for all the changes that are coming from MySQL. So what I'm going to do is to force a change. God, how do you do that? It's simple. A plain old insert into table, blah, blah, blah. So look my finger. Okay, I'm going to hit return. Yay! So I inserted a row in a MySQL table, and then Kafka listened. So it means that the connector is doing what it does. Kafka Connect is able to connect with Pulsar with the KoP enable. So everything is working as advertised, less is less expected, right? So far so good. You're feeling the tasks that I'm doing here. Basically what I'm doing here is, all right, let me implement what people would do in the real life, okay? So let's go to the third scenario, which is, let me close this. I don't need this anymore. The third scenario is stream processing, right? So just very similar to what our friend Kato presented in the previous session. So what I'm going to do in this demo/scenario, it's not a demo, it's more like this is more like a proof of concept that we are doing here. I'm going to use KSQLDB, which is a stream processing technology from Confluent that is going to create a processing pipeline for receiving orders, events that are in a JSON format called orders, and then we are going to create this stream here that basically is going to mimic a very complicated nested structure. So as you can see here, there's a struct within another struct within another struct, okay? So we call this the entry point of the stream. We're going to basically receive the JSON payload as is. Then, and as you can see here, we are dealing with JSON. Then we're going to call this orders. And the next part of the pipeline, we are going to actually select from those orders, that's the next stage of the pipeline, the next phase, and we are going to flat everything out, you see? When we use this operator in KSQL, it means that we are navigating through the graph of the nested types. And we're going to create a column, right? We're going to flat them out, okay? Nested to flat. Okay, so, and more importantly, we are going to actually transform from JSON to protobuf. And just to prove that not only KSQLDB can communicate with Pulsar with KoP enable, but Pulsar with KoP enable can also serve schema registry, which is another conflict. All those containers are here in this folder called stream processing. So as you can see here, I have schema registry from Confluent connecting with the same cluster, and I have KSQLDB server from Confluent connecting with the two Kafka servers, which are Pulsar. All right? Complicated, right? Let's see this working. All right. First, I need to start the stream processing. So there's a script here called start stream processing that basically is going to do this. It's going to spin up for us. Where it is, schema registry is starting, and then subsequently it's going to start KSQLDB server, right? So schema registry is up and running because I can see that's healthy already. Let's follow up with the bootstrap of KSQLDB server. And it's up and running already. Wow, so fast. I think I know what the problem with the M1 chip is. If you use a Docker image that's not has been prepared to ARM64, then it freezes. So those other images, they are prepared for AMD 64, Intel chip. So that I think, I don't know, all right? I might be wrong. So now let's working. Let's connect with KSQLDB because it's just running, right? It's not doing anything useful. So let me connect here. I'm going to use the KSQLDB client for this. Let me make more room here. So as you can see here, I should have no streams at this point because I just started from scratch, right? Then I'm going to actually use this statements.sql file. I'm going to run against KSQLDB to create those streams. So let me get instructions, run script, statement.sql. So I'm going to copy. I'm going to put it here. And it's creating those two streams, right? So I think we're good in time, right, Tim? We have 8 minutes. Plus a little bit of buffer because of the cough break. All right, so cool. I'm glad because we are good in timing because I want you to ask questions after. I don't want to run out of time so you don't have the opportunity to ask questions. So let me show the streams. We should have 2. So one stream called orders. This is the entry point of the pipeline that receives the orders in JSON format, right? That mimics the nested layout. And we have another topic/stream because, just a parenthesis, everything in KSQLDB, every stream or table you create becomes a Kafka topic. Okay, just FYI, so you can understand the logic. And then we have another topic/stream called flattened orders that's going to select from the orders, do the flattening, and transform from JSON to product buffer, right? Let's see if this works, okay? And by the way, if you go show topics, we should see that all the topics that we've created from the other demos. Because again, it's pointing to the same shared Kafka, right? Kafka cluster. So, moment of the truth. I'm going to thank again my friend Kato because she explained in the concept that now I don't have to explain again the concept of a continuous query, right? Because she did in the previous session. So it's a query that never finishes, right? It's continuously waiting for new events to arrive. So this is what I'm going to do here. I'm going to select from that flattened orders, okay? So I'm going to, where's the terminal? Here. I'm going to put this select to place. And as you can see here, it showed nothing because there's nothing in the topic yet. I'm going to produce a message to it. But as you can see here, it never finishes. It's waiting for the messages to come in, all right? So what I'm going to do here in this last terminal, in the bottom, I'm going to create a Kafka console producer, right? So now I'm connected to the Kafka cluster, and I'm going to produce some messages to the topic that start the whole pipeline of processing, right? And those messages, just for you to see, I'm going to highlight one here. So as you can see here, ID, timestamp, blah, blah, blah. And then customer has a nested structure. Let me try to navigate here. Yep. All right. Let me use this rolling bar here. So after customer, we have address that has a nested structure for street, blah, blah, blah. Let me show this here on the code. I think it's going to be way more useful. Where's the README file from this here? Okay. Here we go. Now I can use the arrow keys to navigate. Okay, so as you can see here, I have this nested structure that I have an address that has a nested street, and I have a product that has a nested tape. So I'm going to pass all of this in the producer client, okay? So I'm going to copy. And when I passed, understand this as me injecting messages into the entry point of the pipeline. So I'm going to pass V. No. I copied? Yeah, now I copy. And then, boom. What this means, if you see something coming in, is that number one, KSQLDB was able to communicate with the Pulsar cluster with KoP enabled. Number two, Schema Registry was able to communicate with the Pulsar cluster with the KoP enabled. Number three, all the message processing and storage worked as expected. And more importantly, now we have this topic in a protobuffer format. So message transformation, message enrichment, message layouts, everything working just like you would do in Kafka with Confluent stuff, but with Pulsar. Cool, right?